back
I'm
to
doing well.
the Classic Show. Welcome back to the Immutable Fortress, even though I feel the Immutable Fortress lives inside all of us somewhere.
We're making the immutable fortress all around the world.
Exactly, exactly. It's not restricted to any one location. So thanks for taking the time today, man. You know, you've been doing some amazing work. You definitely deserve the recognition of what you're pioneering with this hashing algorithm change.
Thank you.
You know, I think that, you know, we're definitely going to dive into it. I do want to highlight how amazing it is that, you know, you're doing this on your own. And it shows that, you know, even a project as large of Ethereum Classic can be influenced by all of us, right? So I applaud the fact that you took the initiative. You know, no matter what, this is research that's going to be able to help every single other blockchain. You know, thanks, man.
Yeah, I mean, thanks so much for the recognition. I mean, my philosophy has always been with blockchain technology is that I'm really interested in seeing blockchains as a whole succeed. So for me, I like Ethereum Classic a lot. You know, I'm building dApps on there. I'm doing it partially just because I'm so interested in it. And then another part of it is the fact that I'm trying to build a profitable business on top of ETC. And I think that switching to a better hashing algorithm in which we'll be able to be, you know, sort of the dominant chain on that hashing algorithm is going to be just far better for users. Because right now, you know, if a user of one of the dApps wants to, let's say, turn their ETC into dollars on Coinbase, they need to wait like 2,000 confirmations, which is over like 2 days.
And in context, that's a result of the 51% attack.
Absolutely, yeah.
And you know, these are things you and I discuss a lot. But what is the drawback of the current state of the affairs, where we are the minority on a hashing algorithm?
So right now, Ethereum Classic is about 1/20th the hash power of Ethereum. So that means that for every ETC miner, there's about 20 times more Ethereum miners.
Right.
And the issue right now is that, so the issue right now is that we have the same hashing algorithm. So at any moment, those miners can just choose to turn their data center from mining Ethereum to mining a hostile chain to Ethereum Classic, which is exactly what I believe happened early January, is that there were some Ethereum miners, and either intentionally, you know, I still don't know if it's entirely intentional. They may have just been selling their hash power just to the highest bidder, and whoever bought it happened to do this attack chain. They attacked Ethereum Classic twice. And to me, you know, looking at it, when that happened, I wanted to go back to understand, like, how did Bitcoin work? What is Bitcoin doing differently that has caused it to never get attacked? And, you know, looking at how Bitcoin operated, I kind of was like, well, wait a second, this SHA3 algorithm is incredible. I've been using it all the time programming on Ethereum. So, you know, as like a software engineer, to me, it's kind of crazy the idea of having two different hashing algorithms in the same system. Like, why don't we just use one that's the best? So I started digging into that, and then it became very clear to me that, oh my gosh, not only is SHA3 like the best algorithm by far that exists today, it's the safest, it's the highest performance. Nobody else is using it. Like, there's literally no other chain right now that's actually using it. And what's even crazier is that there's been chains that have started other algorithms like Blake or Grossel. So Decred is a huge chain, and they chose Blake as an algorithm. And like, you can look at the documents and you can actually see that Ketchak and even SHA2, Bitcoin's algorithm, is way higher performance than Blake. So I think that we are just so incredibly lucky that there has been no other chain that started using SHA3. And this is just a fantastic opportunity for the ETC community to kind of take its own algorithm and really seize the best algorithm out there right now.
Right, stake a claim onto this hashing algorithm that not only it removes us from being the minority in an existing hash, but then makes us the only in, you know, what seems to be one of the fastest and the most secure hashing algorithms out there. Is that really the gist?
Yeah, so that's the big idea. And I think another thing that I want to emphasize is that and this is what I learned through the studying, is that not all hashing algorithms are created equal. There are better hashing algorithms and there are worse hashing algorithms. So, and it has to do with things like safety. So how likely is it to be attacked? Performance in software, performance in hardware. And, you know, if you go back to the history of SHA3, it went through almost 10 years of really rigorous competition put on by the government, by NIST, starting in 2007 to find a replacement for SHA2 in case SHA2 got broken. And really, Ketchak went through so many tests, and it came out on top on all of them. And then it got the sort of SHA3 designation because of that. So in my opinion, it's a no-brainer that this is absolutely the best algorithm for us to kind of stake our claim on.
And it doesn't seem that anybody has had a counter on that point. It seems that the community agrees that, look, SHA3 is a better hashing algorithm. I think that you've won that argument. And now maybe,
yeah.
You know, what do you think is the valid concern? Is it more about like miners?
I think the biggest concern has to do with the ability to build ASICs for SHA3. So when Ethash, which is the current algorithm that we have, so actually let me just first define exactly what an ASIC is, because this is really important to understand. So you and your computer right now, like what we're on, we have a CPU, and CPU, multi-purpose. It can do everything. It can do it, so it's really good at sort of doing different things. And then you have another thing, which is a GPU. And a GPU is similar to a CPU, but it's a lot more specialized. It's really good with doing small tasks, a lot of small tasks concurrently, which is what you need to do video games and graphics processing, that kind of stuff. Now, it also happens that GPUs are also really, really good at mining, because it's doing a lot of sort of small processes. Now, what happened starting around maybe 2010, 2011 in the Bitcoin space is that people were doing mining with GPUs, and they were saying, okay, well, what happens if we go even one step further than a GPU and we build a device that can literally just do one application? And that is what a definition of an ASIC is, an application-specific integrated circuit. So you print them out on a board, and you literally cannot change it once it's been created. It can only do one thing, and it does it incredibly fast and incredibly efficiently. So the thing with Ethash, which is what we currently have, is that was created in 2015 under the assumption that it's memory hard, so it's difficult to build an ASIC for it.
Right.
That was how it started. And I honestly never even looked into the hashing algorithms of Ethereum before the 51% attack, because as a dApp developer, it's not really like my area of expertise. I mean, it's cool for the miners, but it doesn't really matter to me.
Right.
But then once the 51% attack happened, and basically the entire economy built on top of this Ethereum Classic was disrupted for a period of like 48 hours, then it became my problem. And I started looking into it, and I'm like, well, wait a second, we're using this algorithm that was supposed to be ASIC resistant. And now it's very clear that not only are we a minority chain on it, which was not how it was originally designed. Like the original designers of Ethash never thought of this dynamic of being a minority chain.
Right.
And then second of all, I don't even think that the premise of ASIC resistance is even true anymore, because every coin that has said it's ASIC resistant, once it gets to a certain market cap, it then becomes profitable for people to try to build ASICs for it, and then they always succeed. So coins like Litecoin, Ethereum, Zcash, Monero, all of these were designed to be ASIC resistant, but once they became rich enough for people to actually be incentivized to create ASICs, they just built them anyway. So I think that the biggest criticism against this switch to SHA3 is that it's going to bring ASICs onto the network. And my response to that is simply that ASICs are already here. They're going to become more prevalent, as Ethereum Classic goes up in value. And we would much rather choose an algorithm that's completely transparent, puts everyone on the same playing field, because everyone can know how to build a SHA3 ASIC. Literally, the creators of the algorithm tell you how to do it. So I think it's going to lead to a much more competitive environment where people can actually like build companies on top of it because they know how this thing is going to work.
Yeah,
And that's sort of a long answer. I don't know if it answered your question.
it definitely does. It has some good follow-up questions. And, you know, ultimately, you as a business owner, you want to feel that you're building something on solid ground. You know,
Yeah.
there are so many examples of companies that built on other people's platforms, which is almost similar to this, that you're building on somebody's platform. You know, like I remember Zynga with their Farmville on Facebook, and then all of a sudden decimated because there was a change. So as a business owner, you care.
Yes.
So there was a choice you made when the 51% attack happened. Instead of looking where to move, you chose to fix. Right? You're choosing, instead of moving PC somewhere else, you're saying, you know what? This is where I want to be. You know, what's your thinking there? Because I think that that's fantastic, that instead of, you know, leaving Ethereum Classic, the overall value is so great against the 51% attack, you know, perceived issue.
Yeah, so I look at it through a very historical lens. So I look at sort of the evolution of these blockchains as similar to the evolution of like societies in general going throughout history. And what struck me is that, you know, in the past, like during medieval times, you have these people that are like farmers that are just farming all day. And that's really what we are right now. We're still in such an early days of crypto that we're basically farming these basic applications. But what happens is that when the villages or the farms got attacked, you had to have the farmers actually go and defend the common infrastructure, defend the town. So when this 51% attack happened, I was basically like running my own little farm, trying to build the applications and stuff like that. I see this tremendous attack happening, very disruptive, and I think that I need to do something. And I think that what will happen in the future is that like maybe 10 or 15 years down the line, once Ethereum Classic is a lot more sort of created, is that dApp developers like myself won't necessarily need to pay attention as much to the core infrastructure. They still need to know about it. But because we're in such an early stage, as someone building a business, like farming on top of it, I also need to be ready to defend the core protocol against attacks, because I'm both interested in it on an academic level, and then also I'm financially incentivized to participate in this development as well, because I want to be able to protect my customers.
Now, was the decision influenced by the fact that what you've built, you've invested so much into the ecosystem of Ethereum Classic that you didn't also, maybe you didn't have the choice to necessarily decouple? Is that also part of the equation?
We got a little bit cut off at the end there.
Yeah.
You said, could you repeat maybe?
I'm really, again, I'm fascinated by the idea that as a business owner, you saw that there was a 51% attack, and instead of considering migrating to a different chain, you said, no, I'm going to stick it out here. Was that because also, you know, you've put so much into the ETC community that is that ultimately it, that the way your interaction with the community is it the community itself? Is it the chain itself? Like, what was that driving factor?
Well, I would say that part of it is the way that the dApp that I work on, P3C, is designed, is that we simply can't move. So there is no, it's a dApp that custodies Ether Classic. So it's not like I can just take the holdings and move it to a new chain. So there's a part of me that's kind of like, you know, I'm stuck and I'm going to make this as great as I can. I'm committed.
Yeah.
And then the other thing is that I really believe in, so like, you know, Donald McIntyre talks a lot about this idea of the Lindy effect, which is the longer that a chain has survived, the longer it's likely to survive. Yeah. So if I move to a new chain that might be safer right now, it doesn't have the history, it doesn't have the community, it doesn't have the immutability set into it that Ethereum Classic has. So I think it's a lot easier to improve the current chain than starting from scratch on a new chain.
Yeah, and you know that in trying to put myself in your shoes, I would really look at the community as the driving force, because again, this is a great example of decentralization. There are not many blockchains where you see this level of collaboration and decentralization, you know, where the community is getting together. I mean, I know that you've published this as an ECIP. What ECIP exactly? What's the number? I forget.
1049.
1049. We'll put the link in the description along with P3C. And you've written, I believe, 2 Medium articles about the hashing algorithm. So I'll put those as well. Now, on the beginner side, would you know, we would have to be starting from scratch on the hashing algorithm for the hashing power for Ethereum Classic?
No. So this is something that I really wanted to emphasize during the talk, or during this call, is that there is no time limit on this switch to SHA3. So the work that I did on Aster, and it's currently like that, everyone should go there. It's open for mining right now. It's open for testing. Put your things on there. I just simply wanted to prove the viability of this change. I do not know what is the correct time frame, whether this is something to implement soon, later. You know, there's been a very interesting proposal that was made by Saturn, which is saying that if we do decide to make this change, we give at least a year in advance for people to be able to participate. And I really like that idea. I like that idea of basically saying we're going to do this in a year. But my goal was just simply to prove this viability. And I learned a ton about the Ether Classic and the Ethereum virtual machine in the process. So I'm just happy that I was able to prove the technical feasibility of a SHA3 proof of work testnet. But in terms of actually getting it merged into ETC and building the consensus for that, I expect that to be a really long journey. And there is no time limit on it for me. I'm in ETC for the long haul. And as long as we get consensus around making this change, whether that takes a few months, whether that takes years, I'm in it for that time frame.
Excellent. And there's, you know, you mentioned the engineering part. Outside the engineering part, you know, focusing on like that community miner thing, you know, what kind of steps would we need to take there? Would that be, you know, miner education? Because if I'm correct on how we do this, we wouldn't be able to have both ETH hash and SHA3 at the same time.
We would not be able to do that. It would be a cutover. So the way that it currently is actually, let me see if I can just share my screen right now.
Yeah.
Did I do that? All right. So this is fun. Okay. Can you see my screen?
Yes.
Okay. So this site is totally available. Anyone can go here. It's called stats.aster.host. And this is displaying the live information about the testnet. It's totally available and anyone can connect to it. So we've already had one person reach out, UMCO Belarus, and they just downloaded the software, connected to it, and they're already starting to write mining software on top of the open source CPU miner that we wrote. Just totally, they found it, they really like it. They're into SHA3. They've been in Ethereum Classic for a while, and they were echoing a lot of the concerns that we had about ETH as well, where they're saying like this state as a minority chain is just not acceptable for ETC. So they're really excited to see this change. Yeah. But really anybody can connect here.
When did you launch this?
So this was launched on May 17th, 18th, around then.
So 10 days ago.
Actually, no, later than that.
Yeah.
No, we did the hackathon 10 days ago.
Yeah.
And actually wrote all the code, and then we cleaned it up, and then we actually launched the testnet maybe like 3 or 4 days ago.
But
so it's still very fresh.
Everybody viewing to understand how fast all of this You know, you'd be amazed how much progress happens in a small amount of time if you're focused. So really, yeah, well, job
Oh
well.
yeah. Oh yeah. I mean, that's the difference between working in a company, which is like a top-down hierarchy, and working in a decentralized space in which I'm doing this because not because there's a manager telling me to, but because I really believe in what we're doing. And let me actually just take a moment to just share real fast the other resources. So this was, we made this yesterday. This is the Block Explorer. Can you see that?
Yeah, very cool.
So yeah, so you can do that. Their Block Explorer right here. And then also you have direct compatibility with Nifty Wallet, which is a fantastic wallet application. So I can send right now. I'm going to do a real thing. So let's send to this account. You know, we're going to send let's send 500 fake ETC, so testnet ETC.
Yeah.
So we're going to do that. We can set the fee. So it's just going right now, and then maybe like right now the network is a little sporadic, just simply because there's so few miners on it.
Right.
But within the next few minutes, you should see that transaction go through. So it's entirely ready for people to start testing with. And I think Zach Mitten was talking about some really interesting stuff he wanted to do with SHA3.
Oh, excellent. Yeah. So what was Zach discussing to do with SHA3?
So what Zach was saying was that the issue with Ethash was that you have to keep, because it's ASIC resistant, you have to keep all this stuff in memory. And what he was saying was, what he was saying was that it's difficult to run a node on something like your phone if you have to have 5 gigabytes of memory to just run a hashing function. So what people don't fully understand with ASIC resistance is that ASIC resistance makes it difficult for miners, but it also makes it difficult for end users. So we were doing some performance profiling on how long it took to sync it to the blockchain. And because Ethash is slow, that adds 2 milliseconds per block.
Oh, wow.
And 2 milliseconds per block doesn't sound like it's very much, but we're producing a block every 15 seconds. So if you're thinking that Ethereum Classic is going to be, you know, a multi-decade long network like Bitcoin, then that number will actually really add up if you're trying to confirm it over time. So SHA3 also makes it a lot easier to sync your nodes as well. And that's what Zach was talking about.
I'm not, you know, I'd love to, you know, to follow up with this conversation with all of us on the ASIC resistance. From a different perspective, I've heard that it's good that you use ASIC, in that you want machines that are dedicated, that there's a sunk cost towards producing the assets and mining. So, you know, even if the ASIC is the only drawback, you know, I'm not convinced that that's an argument.
Yeah, so that's, oh, by the way, this was the transaction. It just went through.
Wow.
So 500 ETC.
Well done. 2 minutes.
Yeah, so that's
like what, 2 miners?
Yeah. Yeah, pretty good. But that's a great question. So the whole like question as to whether or not ASICs are good versus ASICs are bad, I don't necessarily want to get involved with that debate, because so I studied philosophy and I studied computer science in college. So I know the difference between debates that have an answer, like within computer science, and then debates that don't have an answer, like in philosophy. And I just choose to focus on the performance and the data of SHA3, and I let people draw their own philosophical conclusions as to whether or not it's a good thing or whether or not it's a bad thing. Personally, I don't think ASICs are as bad as people think they are. I think the reason why people hate ASICs so much is because if you go back to history, the first people to produce ASICs was basically one company in China, Bitmain. And they started doing it in 2011, 2012. And they were the only ones with serious ASICs from 2012 to like 2015.
Yep.
And it was just because nobody in the market knew that ASIC mining with Bitcoin would be such a big deal. So because they had a monopoly for like 3 years, people now automatically assume, oh, ASICs are terrible, blah, 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 blah.
Yeah,
when the reality,
the centralization, right? It's usually connected with, yeah, the only people who are going to have ASICs are going to be miners, it's going to be centralized. Yeah.
yeah, but that's not true anymore. So if you look at the actual stats, there's like 6 different companies that are all producing ASICs nowadays. You've got InnoSilicon, Bitmain, GMO, which is based out of Japan. You have Bitfury. And I think that with the switch to SHA3, if that were to happen in, let's say, a year from now or in 2020, by then there will be tons of producers. And I think there'll be companies that we don't even know yet. I think we could also see incumbents like Intel or Cisco or like some of these bigger guys also get involved, as well as new companies that we may never have heard of. So again, it's a philosophical question, and it's one of those things where I just prefer to focus on the data.
Yeah, I think you're making the right choice and staying away from that can of worms.
Yeah, exactly.
Would you be upset or honored if another project came and took the SHA3 work and implemented it before we make a decision?
I mean, I would be a little bit upset because I have, like, most of my holdings are ETC, you know, my business is ETC. And if another chain were to come along and then just take the work, and then obviously I wouldn't own a piece of that, any of that digital asset. So effectively, I would just not be compensated at all. I mean, honestly, I think it's a legitimate thing. There's been some Monero devs that were talking about, oh, hey, this ASIC resistance thing isn't going to work out, so maybe we should look at SHA3. So that's something that I think that the community should bear in mind, is that people are starting to figure it out, that ASIC resistance is a myth, and they're starting to know that there's only very few untapped hashing algorithms out there, and SHA3 is the best.
Yeah.
That is not a secret.
And your response,
So yeah,
it shows how much you care about ETC, right? Because
oh yeah, I'm committed, man.
yeah, I personally would have been like, wow, somebody else wants to use, you know, the work, awesome. I'm flattered, but you're like, no, we need to use it. It needs to be on the, you know, this is our opportunity.
Oh yeah. No, it's an open source company. It's an open source thing, but I mean, make no mistake, EPC is a company, and this is like a very, very competitive space right now with, in terms of base layer chains. So we cannot just, you know, start letting other chains leapfrog us in terms of technological enhancements. We have to stay in front of them.
So as a next step, we need to, you know, videos like this, educating the community so that they understand the arguments. I'm sure that there are some arguments that might have been misrepresented either by me or we didn't be able to touch it. If anybody has anything, put it in the comments. You also know that Alex, myself, we're very active on Discord. So, you know, definitely reach out.
Yeah, join the Discord. Disagree with me. You know, I'm totally open to disagreement. Just show me the data and put it on the testnet. So the testnet is entirely open to mine. That's the biggest thing right now. So if you go, you can put the link in the show notes. But yeah, we got this wonderful website that basically tells you absolutely everything that you need to know in order to start mining. So it's aster.host, and you just follow this stuff right here. Takes you 30 minutes to get the node set up, 5 minutes to get a miner set up. And then if you want to get onto the special page, it takes another 5 minutes. And then you can start transacting on the network directly via the Nifty wallet right at the end of that. So if you care about ETC, you care about SHA3, I mean, definitely just download the node and just get on the network and start playing around with it.
Amazing work, Alex, and thank you so much for, you know, sticking with it and going above and beyond. I know you did it for your business, but really we're all, you know, we're lucky to have you.
I mean, I'm green at heart, man. Green at heart.
Another Emerald Warrior. And
Emerald Warrior, dude.
Guys, audience, everybody watching, check out the SHA3 Aster Network. Get involved. We'll put all the links. Alex, thanks again for your time.
Thanks for having me on.
By the way, you're the only person that's been on the show twice now. So we're gonna start keeping count. Alex has the record, and well deservedly so. Take care, brother.
All right. Thank you, man. See you around. Bye bye.